Hey guys, BuildZoid here, and today we're going to do a bit of a rant video. Hopefully I managed to keep it kind of short, but basically addressing a comment that I've seen sort of under my videos every so often, which is that motherboard vendors lying about phase counts is a new thing. And I guess maybe if you consider the year 2008 to be relatively recent, then sure, motherboard vendors lying about phase counts is in fact new. However, in 2008, I didn't even know what a motherboard is. And so to me, this has been happening for ages. Motherboard manufacturers have been lying about phase counts. Then I came along, got really annoyed by it. I've been trying to get them to stop doing it, and failing to some extent with some of them. But anyway, so today we're going to take a quick look at the VRM of the Gigabyte GA-EX58 Extreme motherboard, which at Gigabyte back in the day advertised as a 12+2 phase. This motherboard, again, is from 2008. So in 2008, we already had fake phase counts. And all you really need to see in order to know that this motherboard can't be a 12-phase V-core, the rest of it is fine. The +2+2 part, that's fine. It has that. But the 12-phase V-core, I mean, all you need to look at is the back of the board and just sort of, you know, if you know anything about how a buck converter works, you can look at this right here and you'll notice that, wait a minute, aren't these two inductors connected to the same switch node? So how are you supposed to switch the current through these two inductors independently? Because they're connected to, like, they're in parallel on the input side. Of course, on the, like, all of the inductors output into the same power plane, so the output of all the inductors is in parallel. Like, all your phases ultimately, you know, end up, like, your phases ultimately all run in parallel, as in, they have 12 volts coming in from the same 12-volt source, and they output V-core to the same V-core power plane. But the whole separation between the phases, like this right here is your separation between the phases, right? Like this is a phase, this is a phase. So we've got 1, 2, 3, 4, 5, 6. Except I'm pretty sure the Gigabyte motherboard website said this is a 12 phase. And then on the front of the board, yeah, we've got 12 inductors, we've got 12 high-side MOSFETs, we've got 18 low-side MOSFETs. Yeah, like, because here's the thing, those are 2 low-side MOSFETs in each phase, and then on the back of the board, if you were wondering what the hell is going on with these, those are more low-side MOSFETs, because as far as I can tell, when Gigabyte designed this motherboard, they decided to use the same MOSFET absolutely everywhere. And the problem with doing this is normally you select your high side and your MOSFET, low side MOSFETs to be different so that you can optimize the low side MOSFET to have lower RDS. Like you can choose a lower RDS on low side MOSFET, which switches slower but has a lower resistance. And since the low side handles most of the current flowing through the phase, you want the resistance to be really low, and you don't need to concern yourself about the switching too much because it's not actually switching a relatively high voltage. The high side MOSFET, on the other hand, is switching 12 volts on and off, and so you want it to switch really quickly, and the resistance isn't as much of a priority, even though, again, if you have a super high resistance high side MOSFET, that obviously sucks too. Yeah, so normally you would use different MOSFETs for different functions, but Gigabyte, when they designed this motherboard, just kind of went like, no, it's cheaper to just use the same MOSFET everywhere, and if we need a lower RDS on, we're just going to put more of them in parallel. So that's exactly what they did, and so this 6-phase VRM has 2 high-side MOSFETs per phase, 2 inductors per phase, and 3 low-side MOSFETs per phase, which is pretty unique, because these, like, having 2 low-side MOSFETs in each phase is actually pretty normal for high-current VRM designs. Actually, it's really common that you'll see like 2 low sides with 1 high side MOSFET because, again, the resistance of the low sides, like, that is really critical to get as low as possible, and then having more low sides in parallel further, like if you find a 2 milliohm RDS on MOSFET, well, if you put 2 of them together, now you have a 1 milliohm RDS on low side MOSFET for the phase effectively. But anyway. So yeah, having multiple low side MOSFETs in a phase, that's completely normal. There's nothing weird about that. Putting the inductors in parallel is, well, it does what it's supposed to. Like, let's say each of these inductors is a 20 amp inductor, and Gigabyte wanted to design a VRM with over 200 amps of output current, and they have this ISL 6336 6-phase voltage controller. then yeah, putting, you know, two 20 amp inductors in each phase gives you 40 amps of current, like inductor current capacity per phase. So now you have a 240 amp 6-phase VRM, at least in theory. You could have also just bought a 40 amp inductor, just, you know, instead. Now, obviously, if you're building other motherboards where you're using those 20 amp inductors, then yeah, putting multiple 20 amp inductors together to get 40 amps per phase is actually like, it's a nice little cost optimization trick you can do. But you could also just buy a higher current inductor instead. Like that's also always an option. Yeah, so this is very much a 6-phase, right? 6-phase controller. You saw on the back of the board, like the freaking inputs of these inductors are tied together. Every 2 inductors share a switch node, so it's physically impossible to have those inductors running out of, like to run the MOSFETs out of phase. There's only 6 drivers on this board. They're all over here. These are ISL 6609 drivers. So we've got our 6 PWM signals going from the ISL 6336 into the ISL 6609s, and then the 6609s switch on and off 2 high-side MOSFETs and 3 low-side MOSFETs in each phase. So this is a 6-phase VRM, and there's not really much else to say about it for the V-Core here, but of course Gigabyte was advertising this as a 12+2 phase. Now, I'm not ripping on Gigabyte here intentionally. Gigabyte is just unfortunate enough that of all the old motherboards where this is very easily like demonstrable that the phase count is just completely incorrect on in the marketing materials. They're just unfortunate that I found one of these on eBay for 25 quid. It's very unlucky for them that somebody bent a few pins in the socket and decided to list it on eBay. Unfortunately, I never got the board to fully to a fully functional condition. The middle memory channel is dead on mine, even after I straightened out the pins. Like, I got the other 2 channels working, but the middle one's still gone, which is a bit of a shame. But yeah, anyway, so the V-Core is not a 12-phase, it's a 6-phase. Now, the other 2 rails, the +2 and the +2, those are fine, because one of them is controlled by an ISL 6312. That's the I think, CPU VTT rail, it's called. And that's a 4-phase controller with integrated MOSFET drivers. And so if we look at the board, that's this VRM over here. If we look at the back, you can clearly see that the switch node is separated right there, right? This MOSFET is not connected to this MOSFET. Now, it is an 8-layer PCB, so just looking at how the top layers are laid out is not, like, super reliable, but, like, if they're separating this right here, then why wouldn't they be doing it also on the lower layers? And also, like, this VRM has a 4-phase controller. There's no reason to be running this as a single phase when you have more than enough phases to do a 2-phase from the controller. Then we have the memory VRM, which is the same situation, right? You can very clearly see that the inductors are not sharing a switch node, and then they output into the same memory power plane, because yeah, that's just how that works. And I close the image. On the front side of the board, the memory VRM just barely didn't make it into the photo, but that controller over there, that's a 6322G, which is a 2-phase controller, and then here we have our 4 MOSFETs, you know, 1 high side, 1 low side for each phase, and that's all very, very normal. And actually, the CPU VTT, we have we have 2 high sides and 2 low sides in each phase, right? Which is why we have, because there's 8 MOSFETs. Yeah, we've got 8 MOSFETs over here, so each inductor actually has 4 MOSFETs connected to it, whereas over here we have 2 inductors connected to 5 MOSFETs. And you can't really say like each inductor is connected to 2 MOSFETs or 4 MOSFETs, because there's 5 MOSFETs connected to 2 inductors at the same time. So yeah, V-Core is a 6-phase, the other rails are 2-phase, as the Gigabyte marketing materials claim. And so at this point you might be wondering, why did nobody call this out in the past? Like, why did it, basically, I'm pretty sure I'm the only person to ever complain, like, or at least I was the first person to complain about the fact that motherboard manufacturers have been, like, falsely advertising their VRM phase counts for years. This motherboard is from 2008, okay? And the thing is, as far as I'm concerned, the main reason motherboard manufacturers were able to get away with this is because motherboard reviewers of the past neither knew nor cared how a VRM works. And so when the motherboard manufacturer came along and said the VRM is a 12-phase, they went, sure. And as a few examples, I managed to dig up a pair of reviews of the EX58 Extreme here, and this is very yeah. I don't know that this is a good idea to be pointing out other people's like reviews have mistakes in them, but like, you know, if people were wondering why this happens, well, it's because most motherboard, like, they just copied the marketing statements from Gigabyte over here, right? Like, this is literally just a copy paste of what Gigabyte has on their website, as far as I can tell. Isn't it? Unique on-off charge. Oh, no, so the slightly rearranged copy paste of the Gigabyte marketing materials. Anyway, scrolling through, we get to, do they discuss the VRM? They discuss it here. So here is the star of the show. Gigabyte continues with the tradition of color coding the board with blue PCB and white for the slots. The board is a 12-phase design, which I don't even know what that it's like supposed to mean. The VRM is, I mean, like, if they said the V-Core VRM is a 12-phase design, that would make sense. But if the board is not a 12-phase design, you've got a 2-phase memory VRM, you've got a 2-phase CPU VTT. There's several single-phase converters hanging around in the chipset area because the chipset needs power, and there's like some secondary rails. Like, let's just pull up the picture again. All right. Like, what's this over here? That's one phase over there. That looks like another phase. I'm not entirely sure it is. On Gigabyte motherboards, it's kind of hard to tell sometimes because Gigabyte really likes to use MOSFETs as linear regulators occasionally. So, you know, if we just added up all of the phases present on this motherboard, I'm pretty sure we're looking at something around 15. Actually, no. 17 or 18. There's probably 17 or 18 phases on this motherboard. So I don't know how this motherboard can be a 12, or actually no, it's not. Well, assuming that Gigabyte wasn't lying about the VRM, this is a 17 or 18 phase design. No, we know that they're lying about the V-Core, so in reality it's more like an 11 or 12, where we have, is it 11? Yeah, because you'd have 6, then you have the 2 plus 2. Yeah, so you'd have like 11 or 12, depending on if you're like how many supporting single-phase converters there are in the chipset area. Yeah, but I don't think that's what happened with this statement over here. So like there might actually be 12 phases total on this board. But I have a sneaking suspicion that's not actually what they're referring to. Which should be more than plenty for even the most hardcore overclocker. The truth is that it really does not matter much number of phases, but it is how they are designed to be able to deliver clean power to the component. The Extreme sure does an excellent job here. As we can see, the motherboard is made with all Japanese solid capacitors, lower RDS MOSFETs. Like, I tried to look these MOSFETs up, and it's not easy, but like, lower than what? An ohm? Like, I hate this statement. And to be fair, it's a Gigabyte marketing statement that they use a lot. That they're like, oh, we use lower RDS on MOSFETs. And it's just like, compared to what MOSFETs? Like, is there some standardized high RDS on MOSFET that I'm not aware of? But anyway... ferrite core chokes. I'm not sure I've seen any other material ever used for the cores of inductors, at least on motherboards. 2 additional power phases are on the memory. Okay, no, we can from this we can conclude that they were referring to the V-Core VRM, which, because, yeah, so we've got a 12-phase design of the motherboard, but then we have 2 more phases on the memory, and then, what, did they just forget about the CPU VTT rail? Ah, they forgot about the CPU VTT rail. I mean... who cares? Like, it's just the CPU's memory controller. Everybody knows memory controllers don't matter. Like, anyway, so yeah, so this gives you some idea of how Gigabyte and other manufacturers in the past were able to get away with statements like this, because this looks like somebody copied a marketing statement. And then we have this PC Perspective review, which, like... man, where is the VRM discussion? Yeah, like, how, like, they have this photo of the board. Then again, I guess you really do have to know how a VRM works in order to get extremely suspicious of those switch nodes. I mean, you don't even need to be suspicious. You see those switch nodes and you know it's a 6-phase. Like, that's all there is to it. It's just like, this is wired like a 6-phase because it's a 6-phase. Like, there's not much discussion to be had on that. Like, you could remove half of the inductors in that V-core VRM and the VRM would still run because it's a 6-phase. Actually, you could replace you could replace all of the inductors in the VRM with just 6 inductors, and assuming you stepped up the current rating and the inductance correctly, also assuming that the VRM doesn't use DCR for current sensing, it would still function properly. And by DCR, I mean the resistance of the inductors. Oh, here we get to the VRM. So to round out our overview of the layout of the EX58 Extreme, we move our focus to the power components around the CPU. Stable power is a major concern for overclockers in general, and the EX58 Extreme doesn't disappoint with the custom 6-gear power phase switching technology. I have no idea what that's supposed to mean, but sure. Each power phase includes 2 MOSFETs. My man, I like... what about this guy? Huh? What about this guy? So, I don't like that MOSFET just doesn't exist. Because that's the only way you, like, there's 12 high sides, there's 18 low sides. So, but anyway, let's keep going. Each power phase includes 2 MOSFETs, 1 inductor, and 1 solid capacitor. So first, so again, here we're working on the assumption that this is actually a 12-phase, which we know it isn't because of how it's wired up. But so up until we get to the capacitor, this is kind of like if it was a 12-phase and there wasn't that third low side MOSFET on the back of the board, this would mostly work. This statement right here. But then we get to the end 1 solid capacitor, which just doesn't work at all because that's just not how the capacitors work. Okay? Also, there's not 12 of them. There's 17. Like, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We've got 17 capacitors on the output of this V-core VRM. Incidentally, they're all in parallel because they're on the bloody output of the V-core VRM. And so how the hell is there 17, like this is a 12, apparently Gigabyte claims this is a 12-phase VRM. So if this was a 12-phase, how is there 1 capacitor per phase? And also, why is that even, like that's not even a thing. Like, that's not how the capacitors bloody work. They're in parallel. Like, all of the phases are connected to all of the capacitors at the same time. So, yeah, using this type of power switching system helps optimize the PC's power efficiency between light and heavier loads, which I guess they're just referring to the fact that it has light load efficiency enhancement, which proprietary active phase adding and dropping with diode emulation. So basically, diode emulation means when you're pushing very little current, the VRM stops using the low side MOSFETs because the energy spent switching the low side MOSFETs on and off is more than the energy you save by having the lower resistance. Then you have the proprietary active phase adding and dropping. So basically the VRM can go from like 6-phase operation down to single-phase operation depending on current draw. That's what they're referring to in this review, except I'm pretty sure this is, again, just sort of like, well, this is what Gigabyte told us it does. Also, there's a lot of motherboards where you have various, like, phase shedding capable controllers where the phase shedding is just not running at all. Like, once you start overclocking, the VRM just locks itself into full phase, like, all phases running all the time, and it just stays like that. But anyway, so, yeah, this is my rant about just manufacturers advertising phase counts incorrectly for years and years and years and years. It's not a new thing. I don't know who started it. Gigabyte's just really unlucky that I happen to have a EX58 Extreme, so sucks to be them, I guess. But you know, nobody in the past was bothered by the fact that like the just yeah. Like there's not much more for me to say on this. It's just like this is a 6-phase, and like this like yeah, there. So that's it for the video. Yeah, hopefully I don't need to read any more comments about how, you know, like VRM phase count, like because the thing is, like, I get annoyed when I see people go like, oh, like I've seen comments where it's like, oh, Asus is so bad for lying about phase counts, or MSI is so bad about lying for lying about phase counts, or Gigabyte is so bad for lying about phase counts, or ASRock is so bad for lying about phase counts. They've all been lying about them for years. Nobody cared until I came along. And actually, I'm still convinced that the only person who actually cares is me. So, and ultimately, it's also worth noting that this is just completely irrelevant. Like, the funny thing is, like, the phase count doesn't even matter that much. How many phases your VRM has, in and of itself, is not a design goal. The design goals of a VRM is to be efficient and to, you know, have fast transient response, and to have, well, that's actually kind of like be efficient, have good transient response, and like good voltage regulation, which basically is a function of transient response is a function of voltage regulation. Having low ripple is a function of voltage regulation. So basically it's just be efficient, have good voltage regulation. By voltage regulation, I mean, if, you know, the VRM is set to output 1.3 volts, how good is it at outputting close to 1.3 volts? How close can it get to actually producing exactly 1.3 volts throughout all the load changes that a CPU will subject it to, or whatever other voltage? Oh yeah, and also actually, well, efficiency and thermals are actually two separate things. Like, you can have a very efficient VRM, but if it's very dense, it'll still run really hot. So I guess, yeah, you want an efficient, cool running, well-regulated VRM. Those are your 3 design goals. You can do that with as little as, depending on how much current you need to handle, you can do that with as little as 4 phases and as many as 32. I've never, like, I don't think you can really go, like, there's kind of a limit to going over 32 imposed by the voltage controllers that are available. Also, please, like, 32-phase VRMs are so silly. Though, funnily enough, there are actually multiple motherboards with real 32-phase VRMs, because eventually we started getting doublers, and so when a motherboard manufacturer wanted to really crank up the phase count, they could just smack a bunch of doublers on it, and they didn't have to lie about how many phases they have anymore. Yeah, it's like the phase count is not a design goal. There are benefits to having higher phase counts, but in and of itself, having a lot of phases doesn't actually do anything. Because you could have a 16-phase using garbage MOSFETs off of AliExpress, and the whole VRM would be trash. And the fact that it has 16 phases is completely irrelevant to the fact that it's still trash. Right? So that's kind of the thing. So, like, I also don't get why it is that motherboard manufacturers started advertising phases in the first place. Because it's like, well, I guess it was like this is a fundamental, like, actually, I can't, well, this is the problem, is like, how do you explain to your not very well-informed customers why your power delivery design is better than your competition's? And so, you know, somebody, and I don't know who did it first, but somebody probably was like, well, our VRM has 4 phases, and their VRM has 3 phases, therefore our VRM is better. And, you know, both of those could actually have 3 and 4 phases. And so then it's like, okay, and so when that starts out, eventually people are like, oh, so more phases, more better. And then we get to the point where, you know, we suddenly have motherboard vendors going like, oh, we've got a 12-phase, when it's actually a 6-phase. But anyway, so yeah, this is just something I wanted to complain about, is just like phase count is not a design goal, and phase counts have been like incorrectly advertised for years. It's not a new thing. It's been happening for years. It's getting better now. I wish we could just like kill the phase terminology. Like we shouldn't talk about how many, like from an efficiency perspective, the only thing that really matters is how many MOSFETs you have in parallel. So like if you have like this you could advertise it as, oh, we've got 18 low sides. And even that is kind of useless because you could have 18 low side MOSFETs with 10 milliohms RDS on, and your VRM would get absolutely demolished by by a different design that only has 12 low side MOSFETs, but they're like 2 milliohms RDS on. So that's like VRMs are too complicated to put in marketing materials is basically the problem I'm getting at here. Is like, this is way too complicated a topic to have like one-liner advertising materials about how your VRM is great, because that just doesn't work. Also, now we have the whole like, smart power state, like the various power stages where it's like, oh, we're using 90 amp power stages, and it's like they have basically the same efficiency as the 70 amp parts. And then it gets really wacky when you get into some of the, like there's some 50 amp power stages that have like a ridiculously high peak efficiency and then they like fall off really quickly. So they're actually like in their optimal current range, they'll potentially outperform like a 60 amp part, except the nominal current, but because they can't handle really high outputs, they have a lower nominal current rating. And then you wouldn't want to run any of those power stages at the nominal current rating anyway, because if we pull up something like an IR3575, so this is a 60 amp power stage. They only go up to 55 amps in the data sheet. And the reason they only go up to 55 amps is because at this point, that power stage is producing 9.5 watts of heat. 9.5 watts of heat. This thing is going to, like, you will never, ever be able to cool that. Well, actually, no. If you water cool the VRM, then yeah, you might be able to achieve that 55 amp current output. But it's a terrible idea. Like, that is not how you're supposed to use the power stages, right? Generally, you're going to want to have somewhere, you're going to want to be somewhere in the, like, 2 to 4 amp heat output range, because much past, like, even, like, up to about 2 watts, you can actually get away with almost no heat sinks whatsoever. Once you start going past 2 watts, you need more and more heat sink. Once you go past 4 or 5 watts, it gets really difficult to maintain low operating temperatures. So anyway, yeah, so phase, we've been lying about phase counts is not a new thing. And honestly, I like trying to turn VRM design into marketing materials. Like, I can appreciate that it's very difficult to advertise VRM designs, because it's like, how do you explain to people why your VRM is better than your competitor's VRM when most people don't even know what a VRM is or what it does or how it works? Like, I can totally understand, but that doesn't change the fact that this statement is just completely false. And then it's also sort of like, but isn't that the reviewer's job to, like, but, well, anyway, so that's it for this video. Oh man, I made it way longer than I was aiming to. Oh well, whatever. Yeah, so this is really random that I brought this up. It's just, I recently saw actually, no, it's not super random. I recently saw, like, I think earlier today, I saw a comment under one of my videos, which was like, they advertise phase counts because of you, BuildZoid. No, they don't. They don't do it because of me. I wasn't interested in buying motherboards in 2008. I had no idea what a bloody motherboard is. So anyway, that is actually it for the video now. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. If you'd like to support, yeah, there's Patreon. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. Yeah, if you check out the Teespring or the Patreon, that would be much appreciated, as they help out immensely with running the channel. And that's it for the video, so thank you for watching, and goodbye.